I am 5 minutes early to the contest this time. Should I wear something else? I'll get a cloth and wash it this time properly. Cloth is it? The fuck, my cloth is gone. My specs cloth. I got my cloth. I'll use this spray. It came. I just wanna be part of your symphony. I have Britannia cakes. I have some Dodge fancies. And obviously have muzzles. And I'll also have water. Can I get positive rating finally? I came so down. I came to 1699. I think last contest was so bad I didn't even upload the video. Contest is about to start, guys. Let me add June 18. Let me get some more water. I just wanna be part of you. I should sing some other song that I know properly. God, you look so great. I should try to focus on the contest, I guess. Like, I have to focus on each of the problem and try to give my best. I have to be desperate to solve, I guess. I cannot just be like, I'll solve one difficult problem and I'll consider solving E as solving B, C, D, E. That's bad, I think. What the fuck just happened? Three, two, one. Here we go. Oops, I messed it up. Quack the duck has returned and found N Tower standing in a land. The heart of the ice tower is there. He wants vengeance for the destruction of his ecosystem and has vowed to wreak as much havoc as possible with his laser gun. Quack will operate on each exactly once in an order. In any order he chooses, the operation on Tower as follows. Quack climbs to the top of the tower and shoots the laser to the right, cutting the first taller tower that hits uh, down to the same height as the tower eye. So he shoots a thing. So the first one, which is greater, will just cut out. Okay, find the minimum possible sum of final hours. Okay, yeah. Uh, I think let's look at suffix minimums. Okay, if you look at prefix suffix minimums, they keep getting smaller and smaller, right? No, 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 no. Okay, let's look at prefix minimums itself. If this is a minimum, all the things after that can be made equal to that. Okay, so everything will have whatever the prefix minimum is, we can bring it to that. And there is nothing better you can do because it will come from something which was in this height, right? So, and everything can be brought down to prefix minimum. How can you do that? Uh, how can you do that? And you will have the minimum, you will have one tree which is not yet been used, let's say. If that is the thing, then when you have one more thing, if it is a bigger smaller minimum, you already achieved your goal. If it is a bigger one, then you can chop it off and then you have such a thing. So the thing, the induction is, you can chop everything into prefix minimums and then you will still have something which is not yet been used and which is the prefix minimum. So answer is just prefix minimum, but I also provided the proof. I also provided the induction proof by telling we can always make everything prefix minimum and have something which is the minimum and which has not been yet cut. I got the answer, but also proved it inductively. So we have to be clear with our proofs, whatever the proofs are. Jaw the ghost is playing with rubber ducks. He has n piles of rubber ducks arranged in a row where the ith pile contains AI ducks. Quack the duck gives Jaw an strictly increasing sequence B1, B2 on Bn and commands him to make the piles M become exactly like this sequence. Jaw performs the process in the following two stages. Jaw may, Jaw may add any number of ducks to each pile. Formally, each pile I he chooses a non-negative integer xi and then he does this. Jaw may reportedly swap to adjacent piles. Formally, he may perform the following operation any number of times, possibly zero. A process is called valid if after both stages and the file sizes is exactly this. Find the minimum possible number of operations performed in the second stage among all valid processes. If there is no valid process, output -1. So one first step is try to make the values equal to these values. The second step is reordering. Okay? And you want to minimize the number of reordering steps. So this is nothing but just number of inversions, right? Yeah, that is number of inversions. But first step is making them equal to this. Maybe some greedy will work and I'm not able to. Ooh, ooh. Sometimes greedy may work. Sometimes the best you can do is bringing the smallest thing here, and then bringing the next smallest thing here, and then bringing the next smallest thing. That's the next best you can do. But sometimes, just let's look at B1. Okay, number of things that are less than B1. Okay, let's look at like this. You have to bring something less than B1 to here, something less than B2 to here, something less than B3 to here, and so on. Okay, anything less than B1 will also be less than B2. B2. Okay, B2, B2, B2. So you have to bring something here. So all you have many things which are all also good for B2. So you bring the first one here. Seems that's the best thing, right? Because if you're bringing something else here and something, because everything else is again eligible. So bringing the first thing here seems the best, because otherwise where will this go? Maybe help something else, right? And something else comes here. Instead that can go there and this can come here. So that's it. It's like a simple problem then. You just have to see that everything less than or equals to b1, everything less than or equals to b2, up to so on. You have to see those colors, and then you know what you have to bring down. Okay, so let's maintain a set that has everything less than or equals to b1, and then move that here. So you know number of moves that should be done now, and then move the other things, and then move the other things, and then move the other things. So 1 minute, should I move them, or can I know the value without even moving them? Okay, N is 2000. So I think I can directly move them because they're not testing our shitty implementation. They're only testing our logic. Because Codeforces is a bit good platform. So what I'll do, find the smallest less than or equals to B1, move it to the forward, and so on. And even after all of this, if it is not being, if there is nothing, at some point, if there is nothing less than or equals to B1, then you are fucked. Filling this position. How do you fill this position? You find the first thing that is less than or equals to this. If there's nothing like that, you have to break two. If there's this thing, then what should you do? You have to swap from there to here. You have to actually swap from here to there. So how would I do the swapping? I'll swap. Okay, now we're here. Draw the ghost is playing with rubber ducks again. There are n piles of rubber ducks arranged in a row from left to right. Initially, the ith pile contains a number of ducks, while the sequence here is now sorted in non-decreasing order. Ja must perform the following operation. Okay, as long as it's non-decreasing, he must perform this operation. Non-decreasing means as long as something is it's decreasing. It's, as long as it's not sorted in non-decreasing means as long as there is something greater than something that comes later. Ja must perform the following operation. Choose two adjacent piles such that the left pile contains more ducks than the right pile. Ja swaps the two piles and then adds the number of ducks in the new left pile to the right pile. Formally, he brings the smaller thing forward and then also adds this to here. For example, if the adjacent pairs, see whenever this has been done, what is happening here? This is a smaller one. Okay, the smaller one will get added to the bigger one. So what is happening is something comes forward, and if this thing has to go backward, what has happened? If I try to see this more properly, there has been a swap. You can see it like there has been a swap, but the smaller thing will get one persistent kind of thing. Means, okay, value also will get changed, right? Okay, thus that value also will become bigger. Okay, one thing we can say, values, the front value has become smaller, the next value has only increased when the swap has happened. Jaw may choose any index satisfying the condition about any step if it can be shown that regardless of his choices, the process eventually ends with the sequence sorted in non-decreasing order. So this is fine to show because it can't keep going on forever because there is some kind of progress here. What is the progress? The number of the value in a prefix has been decreased, right? And value in some prefix can't keep on decreasing. And eventually it will go, I think. Yeah, it must go eventually. Big values will just go to the end. It will end, I think. Joe wants the largest pile at the end of the process to contain as few rubber ducks as possible. Determine the minimum possible value of the largest pile. So yeah, our only goal is to minimize the largest pile that's happening here. We want that to be as small as possible. If a pile can go there and if everything can be less than that value and can get sorted, then you are good because the previous things that get sorted that are able to get sorted by increasing it to this value, those seem to be fine. And if something goes backward, let's see it like this, if something bigger is trying to move backward, it will take whatever in the way, it will just consume that, only in that way it can move to the back. Okay, so let's look at maximum. If it has to move to the end, it must eat everything on its way. Okay, what if there is something that is bigger than that here, then it cannot even move. Only if something else which is bigger than this comes, only then that can eat this and then only then it can go, right? Just wanna be part of your symphony. And the problem is, even if the max goes there, okay, let's say there is max at the end itself and it has moved and it has consumed everything and it has been bigger. If you can't form something smaller, something bigger here, something smaller than that here, then that must also move to the back and that must also consume that. So that seems too much. But one thing I want to confirm or I want to check is, If something is moving here and something is moving here, if something is moving here and something is crossing it, how should we do this crossing? Should first this move and then only should it come? If first this moves and then it's crossing it, that means it is crossing it once it became bigger. We may not want that, or we may want that. We may not want that, I think. Maybe I'm overcomplicating it. Maybe it's easier than whatever I was thinking. Maybe there is a greedy way that just works. But yeah, I can say something like this. If this one moves to the end, it will become this plus everything after that value. And if there is something else which is bigger than that, once it reaches there, then we can have that move to the end. Right? And okay, 1 minute. If this has moved to the end, it has ate all of them. And if something else also eats all of them, it doesn't matter. And I am thinking, I am thinking it's about, because if you try to compare two things, if it is trying to come here, it means it's this plus all of this, only them it can eat. Because if this is also going to the corner, this is also going to the corner, the other things are same. So the comparison is just this plus in between things plus versus this, which looks like this plus in between things and this that we are comparing. So if you just try to do this minus before things, this before things will get cancelled and then this will come there. So it seems to be like the value will be this minus before things somehow. This is like a high level, like a bit high, but okay. And whatever has this minus before things bigger, that will go to the end. Can I just assume that? And then I will just, this seems too much. This minus before things maximum will go to the end. And everything else will just go in that order. We can just sort them in that order. This minus before things that will go to the end. Is that true? The bigger thing must go. So this minus this, whichever is bigger, that will go to the end. Let me try to see that. There is definitely another way to solve the problem. I'm just trying to see something that is not there likely. I'll call it AMP. A minus pref, let's say. And what will be its value at the end? When it moves there, it will be that plus the later things, right? Which is nothing but that value plus total minus the value. Am I overcomplicating it again? Is it just this plus suffix maximum value? No, no, no. Of course, I've been doing shit. Maybe I have to get minimum. I don't know. I have to think, I guess. I have to think I have to think and solve the problem. If something moves there, its value will be that plus everything after that. Right? If after that, if something has moved and then this has moved, will there be any benefit in comparing things? It will only become bigger, and its movement will never help this, I guess, because if it crosses it, whatever it has consumed also it will consume, and then it will consume this thing too. That only makes it bigger. I don't think it helps anywhere. I'm complexing it. Just look at the current maximum, maybe. It must cross all these things. Okay? And then look at the next maximum. Maybe it should cross even more things. And Okay, there will be something less than this. If it has something less than this, that will never become bigger because minimum always persists, right? Even whatever the swaps you do. So you must cross that. For a value, whatever the values you see which are less than this, we can't say all of them will persist because if I try to think of an example, this can get added to that and then they both can get swapped. Okay, can I solve if the maximum less than or equals to this is possible or not? I'm fucking it up again. Maximum must go to the end because everything is less than that. Okay? Maximum must cross all of these things. It crossing now, is it the best thing? Think of that. Because if it crosses later, it will become even bigger. Okay? But if it becomes a bit bigger, maybe when the smaller thing comes from even bigger things, maybe then whatever the benefit it can come from these things, that will definitely, the if something else also comes, also that will consume that benefit. So any benefit over here is useless to the maximum. So maximum moving first is obviously the best thing it can do. But then if something else comes and it actually becomes bigger than maximum, then it cannot do anything. Then it must move forward. Okay, minus previous things is not the right thing. This plus this and this should be compared. I think I missed one thing. I should have been more careful there. But it is not, now it's not becoming a simple formula. Now it's becoming more complex. But one thing I can say is last thing can be moved, and then the next maximum can be moved, and then the next maximum can be moved up to so on. Okay? Is this simpler to solve? What if after all of these movements, if you compare two things, okay, I'm trying to compare two things, this plus this and this. You see, it's the same thing. Then this must cross it. Let's say you have a value here and then you have value here. If it should cross it or not, how do we decide? If this plus everything smaller after that, because it must cross all of them. I'm fucking up an easy problem. I'll go to D. That's bad. I have to think of this problem itself. Okay, at least that brute force is right. 4 will go to the end, it will become 6, and then 3 will come to the end. It will become something else. Mm, at least that brute force is correct. And in that brute force, I only want the final value, right? If something's value is greater than the other thing's value, this plus smaller things after that, if that value is bigger than something else, then it crossing this prior is better. So what the idea I got is correct, but I'm not able to compute that properly. What is it exactly when you compare two things? Is there a gap here? This plus smaller things after that greater than this value. Now I'm complicating it. Are there any easy strategies like to follow here? Can I say anything? Can I say something? I've told so many things, but maybe this brute force can be done and it doesn't matter. Maybe this can be done repeatedly and it doesn't matter. Because the values, how do they increase? If this is being greater than this again, let's say, what does that mean? This plus the values which were smaller than that or greater than this one. Maybe it can be brute forced like that. And how can you prove that? After each round, after each iteration, what will happen? The last one's value will double. So you can brute force this because the last one value will double and it cannot keep doubling, right? So you can just brute force, I think. If you have an array, if you can find number of things smaller after this, you can brute force this thing, I think. So what my first assumption is moving the maximum first to the end is always best. Even if something crosses it or if nothing crosses it. Okay? And then it's at the end. Now moving it till here might always be the best. I think I can just brute force it and it works. While the maximum is not at the end, move the maximum here. And what happens after this? Maximum size will double. No, you cannot just do that. You have to move everything. Do the whole operation of moving the maximum here and then moving the other maximums here and then moving the other maximums here. All of that, the minimum that should be done. Everything has been moved. Everything right now has been moved after its smaller things. If you consider this as one operation, after this the maximum will be doubled. You can say that for sure. No, maybe no. What am I doing? It's not that difficult problem. Let me read day itself. I'm sorry. A binary string is a string consisting only of characters 0 and 1. Two characters 0 and 1 are called opposite values. Consider binary string t modulus of t be the length of t where modulus of t greater than or equals to 2 for every characters or adjacent. A binary string is called beautiful if it can be reduced to a string of length exactly 1 by applying the following operation. Any number of times possible is 0. Consider two equal adjacent characters, remove one of them and insert one character with the opposite value in their place. Remove both of them. Okay, so you can remove these things and then you can do that. If you can reduce it to 1, then it's beautiful. This is not beautiful because it will end up in 1 comma 0 whatever you do. Okay, okay, this is a nice problem. I will work on this one. This is not that nice. I mean, that's also nice, but that I'm not able to get somehow. So I'll try to work on this problem. Maybe I had to use lights, or maybe I have to charge my laptop early. And I want to show my home. This should be a nice and easy problem. Okay, if you think about it, let's try to look at it a bit reverse in a reverse direction. What all are possible? Something, let's without loss of generality, let's say it was 0, and then this is possible, and then only expansions are possible from here, which means this seems to be a possible automation, right? Like with these two things, what all are possible given a 0. Now what all are possible? So this is like a finite automation. with just these two things. If you try to see the reverse direction, is there a property for this two, for this kind of extensions? Is there a property where 0 can become 1 1, 1 1 can become 0 0? What is the property? If I try to look at all of them, one may become again 0 0, and then 1 0 may become 1 1. So what I'm trying to say is, if you can reduce something into that, that means there is also a way to expand back for sure, because you can see back and then you can go back and you can do that. And if there is a way, if there is a thing to come back here, you can again go from there to here, because you can, these are reversible things that we are trying to define here. So the question is this achievable from zero? Number of substrings that are achievable from zero is the question now. And what are all these substrings? How can you check if this is achievable from zero or not? I think these automations can, you can always go and find and compute the first thing that can be reduced to some block. I'm not sure. Maybe that doesn't work. Can you do that? Always. Try to make these two things 0 0 and then 1. Will that work? Try to reduce from the leftmost thing, try to reduce whatever you can reduce. Will that work? But if it is working, can you count it easily? So what I'm trying to do is, if 1 was there and 0 was there and then it became 1 1 1, if you make these two things, it will become 0 1. So, and then maybe this was 1 0. After one operations, what happens? Parity will change, but this is collapsible, this is collapsible, and 0 1 1 is collapsible. So there is a division. We can always assume that this has grown into something, this has grown into something. So maybe we can say there is a division such that this and this will become the same thing. Such a division should exist in between. Are there some things that are achievable by both 0 and 1? Maybe they are, right? 1 0 0, 1 1 0, 1 1 1 0. Maybe here I will do 0 1 1. 1 1 1 1. In one operation, parity changes, and if the length is same, yeah, so there are no strings that are achievable by both, because if you just count number of ones or number of zeros, that changes obviously after every move. Okay, If you see the ordered pair of number of zeros, comma number of ones, what changes after each move? Now I have to be careful. I'm not able to do this too. I'm again complicating maybe. One thing is any big string can be split into two collapsible same character type of things. And once you do that, then the whole thing is collapsible. A zero becomes one one, one can become zero zero. If you see this expanded tree, it is like a completed set of leaves. Okay, let's say compressing few things is obviously bad here. Do we have some things that are good to compress and can you always compress them? I like the way you kiss me. I could never miss me. People solve these days. I don't know why, how. First you have to simplify this there is a property of these things, you have to find that property and then you have to simplify that further. Can this become one and can all of this become one? Zero one zero zero becomes one, one one becomes zero, zero zero becomes one. Can you answer like this? If this thing can become zero, the next thing also can become zero. If the whole can become zero. The first compressible thing. What's the first compressible thing? If you have 1 0 0 1 0 1 0, if you get one compressed, 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 compressed. So is it only these are non-compressible? And if you have one more thing that first time it fails, all of them will get compressed. And to what will they get compressed into? These two will become zero, these two will become one, and then these two will become one, they will become zero. So whatever the first character's opposite is, that will get compressed into that. Okay, 1 0 1 0 1 0 0 also will get compressed into zero because zero zero will become one, one one will become zero, zero zero will become one, one zero, zero will become one will become zero. So you can see this such a thing is there here. And can you always compress things? Unless they are this one, you can always compress this is my question now. Because unless they are this one, this whatever you expand, I don't think you can save this by expanding back and then compressing it. Because if you even if you expand, I think I think this XOR of everything will dictate what. No. Why am I not able to solve these days? I think it's about this even odd partitions. Okay, let's say you have even odd, even odd, even odd, even odd, and so on. I'm trying to see by allowing both expansion and compression how much I can do, but if I allow expansion and compression, maybe anything can be converted to 0 1, because if it is like this, I think you can obviously convert it to 0 1 somehow. Again, convert to 1, convert to 0, convert to 1, convert to 0, convert to 1, convert to 0. What the fuck have happened? And try to convert these two, and then I can simply make all of them as 0. So even that's being possible if I can both expand and compress, but just by compression is different. So just by compression, what you can get is different, I think. So just by compression, you cannot go anywhere here. So the problem is not expansion and compression both are allowed is not like it's not equivalent to that problem. It's equivalent to just by allowing compressions what is achievable and what is not. There are these incompressible strings, okay, which you can definitely not compress. So what is the minimum incompressible string you can think of for any character? Minimum size incompressible string. Maybe if you compress them as much as you can, all of them will get turned into this, or Now if you get a new character 0, let's say, and then you get a new character 0, these things remain incompressible, and will these things will get compressed entirely to 1? Is that how the number of incompressible things can just this DP works? But how do you prove this? I think all these algorithms are, but if I believe in golden rules, if this is true, it should be easy to prove, but they're not being that easy for me to prove. Okay, this can be an algorithm, this can be a solution like one can think of. Okay, if I try to know how many these weird different types of things are there, that gets translated to this and that gets translated to this, then the next thing we'll have, if it is 0, all these things can be translated to a single character. All these things will be can be translated to, so you'll have number of zeros, number of ones, number of zeros, number of single ones, and number of zeros, and ending and starting and ending with ones things. You'll have ending with ones things, and you'll have ending with 0 things after this. You'll have one, you'll have single one or single 0, and or you'll have 0 and ending things, ending with 0 things. No, that may not be right, that may not be true too, that may not be correct too. I'm fucked. I shouldn't do this. I think I should just do work maybe. Let me read E2. Quack the deck has a permutation of length and an incomplete sequence B1, B2 up to on Bn. Each element B is either minus 1 or an integer from 1 to n. For each integer from 1 to n appears at most once in B. Quack hopes to complete B into a permutation that commutes with A. In other words, after replacing minus 1 with B, the equality, okay, A of B of I equals to B of A of I should hold for every one less than or equal to I less than or equal to n. Ja the ghost wants to help Quack. Among all possible ways to complete B, he want to find the lexicographically smallest one. Okay, even this seems good. Even this should be good, but I'm not able to identify that. I'm not able to solve that. My goodness, feeling since you can't get out of it. I'll at least order food for me. This fucking thing doesn't work. I'll think of this too. What does commuting means? What does A of B of I equals to B of A of I mean? And then we have some values missing. We have a permutation. This is a nice problem too. I can think of this problem too. Extra, extra. Dun, 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 dun. No, I can't let road to specialist happen. I will solve this. I will solve C and D too. First thing is you have to identify what are commutative permutations, and then you have to identify what is the lexicographical commutative permutation. Okay. A of B equals to B of A, which means A equals to B A B inverse. If you look at permutation matrix, what is permutation matrix? The first, yeah, there can be something called permutation matrix, which is like one one, all zeros and one one, right? Like which will take this position and then puts that here. So you can see permutation matrix. If you see permutation matrix, they should be commutative. Like row one equals to just where p of one is there and then like this. Because now if it gets applied on a column, only that will become one and that will become this value, right? No, but this is being weird. I think. Maybe there is a better understanding of this. A B equals to B A. What does it mean? A of B of I equals to B of A of I. Let me look at the cycles. Let me see two types of cycles. Let me see both types of cycles. Okay. AB equals to BA. Which means if you travel through some yes, some ways, it only matters to travel, only matters number of A's and number of B's. And this should hold true for everything. Okay? AB equals to BA means this should hold for everything. Like I think this is just better. This should hold for every I. What does that mean? If you take a red edge and then a green edge from any value, one red and one green. Instead of that, you take one green and one red. You end up at same value. This should happen for everything. So you have some cycles, you have some other cycles. If you take this and this, okay, these two things are in the same cycle with respect to green. These two things are in the same cycle with respect to red. Now, if you take that cycle, this is green cycle and that's red cycle, you should come there again. So what does it say? For an I, let's say, let's look at A of I, B of I, AB of I. Okay, B of I also should be the same. So these two are in red cycle, and these two are in same green cycle. Okay, so it says something like they have to form like a triangle. They have to form like this thing, I think. Okay, let's say you go from this node to this, and then you go from here to, okay, and instead now you go from this to green. Let that value be something else, where a of I and b of I are not equal. And then what should happen? For all these things, b of I and a of, for all these things, this should happen. So you can see that these two are in same cycle. These two are in same cycle. I think it's like two dimensions. And then you should be able to also identify what is the lexicographical is fill the remaining things. Fuck. It may seem difficult, but it might not be that difficult. Is there a simpler way to look at the problem? We have to also determine if it is impossible. So what all permutations can go from what all permutations are commutative? Like one thing, if two cycles are identical, then it's sure. Okay, if there is two cycles completely identical, then it's sure. And if there are two cycles but not identical, something is differing. Okay, this goes there and this goes there, but this goes here and this goes here. That's the simplest thing you can think of, where a b is equals to ba or not. It's like it's a, is it a 2D graph is what it's being like. Let's try to plot a 2D graph. Okay, 1 2 3 up to so on n. Okay, here what do? You do, I'll use p comma q, that seems better for me. We have p of 1, p of 2, p of 3, p of 4, p of 5, and so on. And this side you have some other q of cycles. Okay, so it's like a 2D graph where number of p's and number of q's, only that matters if you start from anywhere. Okay, to be clear, one cycle and other cycle are completely independent, right? for I, let's say, if if P of I equals to Q of I, then it implies also that should be equal. Okay? So I can see this one. Because apply B here, apply A here, you got that. Means if for the whole cycle should be equal. Okay, if one edge matches, whole cycle should be equal. This is clear. Okay, this says something important. Now, what about other things? If A of I not equals to B of I, then B of X equals to A of Y. You can say this one. What does this means? If A inverse of X equals to B inverse of Y, then B of X equals to A of Y. Also, A and B can be inverses. Should they be inverse? Should they be inverse? Extra, extra, all about it. Commutative permutations. What the fuck are they? Should they be inverse? They need not be, I think. What do I mean by inverse? If you go back, if you take red also is like, red is like this is what I mean, and green is like this is what I mean. So what I mean, like you have a red cycle and then you have a green cycle that's going behind. So these things also will work because red green you come back to the same position. But that's necessarily, maybe is there some other thing also, or they just cycles or same cycles or reverse cycles, or there is something more. Can the structure be more complex? Okay, I have at least found same cycle and reverse cycles. Let's just say if the cycles can differ, okay? You have a red cycle here and then you have a green cycle here. Can the cycles be differ? Like, let's say there is a value here that is not there in this cycle, and there is a value that is there in that cycle, okay? From here, you consider I here, okay? You consider I's green cycle, and then you have J, which is not there in this cycle at all, okay? No, it need not be equal because identity will always work, right? They need not be inverse. One of them can be identity. I think we never have to do this much math. Okay, AB of I should be equals to BA of I. This is true. If you take one red, one green, they form a cycle, big cycle. Let's try to draw that cycle and see. Let's try to consider A of AB of I. If you look at that cycle to conclude things, what can you say the structure? You have that cycle. Now, one some this will give you AB of I. This will give you AB A square B square of I and so on. So if you see these cycles, I don't think I can learn about competitive permutations in this contest right here, but maybe there is nothing to learn there. Should I try D or E? Should I try C or D? Am I losing rating again? Fuck. Even E has 357 solves. Am I thinking too much? What are competitive permutations? If A of I equals to B inverse of I, another thing I can say is if you have a red and then one green is back, then you can say that it should happen for all the things because red, green, red is coming here. Red, green, red. So red, red, green also should come here. So those are all right. And if one of them is identity, should everything be identity? Red, green. If A of I is red, that means number of greens and then red should be same as number of greens. Okay, number of greens and then red should be same as, and then red, red should be same as number of red, number of greens and then red. Are these three things the only cases that are all that are ever possible? I can Google about commutative permutations, but that we cannot do. Wait, can we can Google without AI's help, right? They're getting applied on same values here. Let me think of it as a programming problem. Okay, let me think of it as a programming problem. Means I'll think of it as a graph problem instead, because there cannot be no theory and still we can solve the problem, right? So let's say if I have some value, if not no value is there, its answer is I. If b of I equals to, if b of x equals to y, can I say something? Then what all can you say? If a of z equals to x, then you can say b of a of z equals to y, which means a of b of z equals to y, which means b of z equals to a inverse of y, and z equals to b inverse of a inverse of y. Or you're able to say b of z equals to I. So can you keep finding base values? Maybe you can. If b of x equals to y, can you find all of, I can do that. A power 0 of x, b of a power 1 of x, and so on can be written as a power 0 of b of x, a power 1 of b of x, and so on. Right. And what does it say? If b of x equals to y, the cycle of x, how the cycle of x moves here, cycle of y must move in the same way. There. Okay, at least one thing is clear. You can know the values of b for all the cycle of x. You can know the value of b. Okay, if you know value of b of one thing, you can know for its whole cycle. It will get fixed. So you have cycles in a. If you know one thing's value here for b, all the cycles value will get fixed. And how will all the cycle value will appear? All the cycles value will just be, okay, now let's look at it like this. For some cycles of a, you have known base, and using them you can know values of base for all of this. Now look at remaining cycles. Okay, you have these cycles, okay, for which you have placed the values, you know the values, and now you have remaining cycles. Can't you just apply identity there? And if you see the base for all of this, my question now is, can you just place 1, 2, 3 in the same increasing order for the remaining things? Will that work? For anything in this circle, okay, does for anything in this circle does let it be a power c of let it be a power c of x. These are the things in the circle, right? If I'm looking at a of x is circle. If I look at x is circle, for all of these values, does b of a of x equals to a of b of a power c of x is what I was trying to say. Because let's look at identity. For that, when b is identity, a of b of x is holding, because b of x is x, so a of x equals to x. A of x, so a of b of x if b of x equals to x, okay, a of b of x equals to b of a of x. See, these problems are easy to guess but difficult to prove, I guess. B of a of x, which is b of x is identity. So what we get is we have to verify this. Okay, a of b of x equals to a of x. Okay, and now if I see b of a of x, x and a of x are in the same cycle, right? So b of a of x is also a of x. So it holds for all the remaining things. For the cycle things, if this thing holds, then I'm good. So I'm trying to prove that. This I'm trying to prove because a power c of x is something in the cycle of x, right? Does this hold is what we have to prove now. And to see this one, we know this thing at least. Because it was commutative, we know this thing at least. Fuck, it's not easy somehow. See, so far it seems promising. I have a solution, but I want to make sure for all these values a of b of x equals to b of a of x. For all these a of for all these things, I want to make sure I know that this is equal to this value because I'm forcing the values on them. It's like computation. Now, after forcing those values, I know that b of a power c of x equals to, I know that this is equals to a power c of b of x because I forced this thing. And now, what do I want to conclude? I want to conclude if this holds true. 1 minute. We have b of a of some value equals to a of b of this value or not. This is what we are trying to see. So what is this b of a of a power c plus 1, which will be a power c plus 1 times this. Okay, and what is this one? B of a power c of x, that is also equals to that. So even this will be this, also that will be that, because b is going inside for both the things. So if this is satisfied, keeping straight, everything will work. So we solve the problem now finally. That's why it's a easy to guess problem. So we solve the problem. It's an easy to guess problem. I can implement it very quick. Now it makes sense why it don't involve any math, because it's involving logic. The involvement of logic was there is no good theory, but if you know one value, you know all the values. If you don't know any values, keep them identity. Easy to code. Because baby, yeah, you just do it cycle wise. You have a b given and you have a potential b. You check their values being equal or not. If the values are not equal, you're done. And once the values are equal, you have the permutation. Yeah, it's simple. It's quite simple. Cause baby, oh my god, bad. I can't sing shitty songs. Why the fuck I got that song in my mind? It's a direct and easy problem. I think I overcomplicated it. I tried saying structure. I tried saying something nice in there, But there is a quite simpler solution, but I proved it very clearly to myself, at least, because I've replaced, this is the question to check. Now it is actually b of a of I equals to a of b of I verified for everything. For the identity case, I verified. For remaining cycle case, I verified. Because if it's for cycle case, b of this value, b of some value is nothing but b goes inside, because that's how we match them. Okay? And a of b of this value, b can go again inside, and then a works out. I'll just keep it as p. Now the question is quite simple. B of x has y, right? So you will know for all the cycle values, you will know that you will know b of value. For everything in the cycle, you know b values. And what happens to them? The values will be these things, which are a power 0 of 1, a power 1 of y. So you have to start from y and then keep applying this thing, and then you will just put all the values there. So you have x, you have cycle length. Let's say you can just run a for loop. You can go over all of them, and then for what will you do for all these things? You have b of that value equals to, you start from y, keep applying a to that. It's quite simple. So what have you done? You started from the next thing, and then if both of them are equal, you have done cycle length is 1. If both of them are not equal, you move to the next one, and then you mark this one and then move to the next one. The next one is thus you are done. Anytime you move to the next one, you did cycle plus plus. So if it is 1 comma 2, you have done cycle plus plus, cycle equals to 1, you moved here. Because you moved here, you have done cycle plus plus. So new one, cycle plus plus, and then move to the next one. Once you reach the starting point, end. So you have cycle length, you have this, and so on. Now you have to identify for any of this j, if any here, if here, for any of them here, let's just collect them too. What's wrong in collecting them? Okay. for any of them, if b of x not equals to minus 1, then you have your x. I'll break after that, but now what should you do? You have your x, so you can find all these values. For all the value of that you can find. Let me just put p of x equals to b of x, and then what will I do? I'll just start from x. Okay, I will also have y equals to b of x. You can see very clearly that b of x and y are in the matching, and as this keeps going, b for all the b's, you just have to do yeah, and so on. Okay, once you go to the next one, you have to do a also, and then you just have to do b of x equals to a of x. So what should you do here? For this length, you have to do b of x equals to y, and then you have to do x equals to b of x, y equals to a of y. Sorry, x equals to a of x, y equals to a of y. See, x is like inside x we are going a of z, a multiplying, and y will keep multiplying outside, y will be multiplied, and then they all will be equal. So this will mark everything in the cycle, because x is going from when it was 0 we assigned, and then we will assign for the whole cycle once. X power 0 has been assigned, x power cycle minus 1 will also be assigned, so everything has been assigned. After assigning that, if b of x not equals to p of x, see out no written, and now the answer is done. See out s so 1 2 is a cycle, and then 3 4 is a cycle. Okay, once you're at 3 4, you know that b of 3 is 4, a of 3 is also 4, so you will get ah oh, now I got that. Pass please. Has the problem not been solved yet? Yeah, it's not solved. The thing is, you cannot assign the logical flaw that I did here is you cannot assign identity to the rest because that may not be possible to do so. But can you just fill them 1 to 3 with the remaining values? Will that work? Whatever the remaining values, or just fill them in the order. No, it's not done. How to fill the remaining values is still left out. And it's not that easy. I'm not knowing what to do there. It might happen that there is a contradiction in this itself. It might happen that there is a contradiction here itself. You move in a cycle here, For those values, you move in a cycle from why. Okay, that means there is a parallel cycle going on there. It's not that easy, but Okay, I see it now a bit. How 25 minutes, I have seen it now a bit. How I have seen it now is we have cycles here. I'm thinking these cycles will form a cycle like this. It's a two-dimensional cyclic sphere. 2D cycles. Let's say you have 2D cycles like this, and this cycle like this. It's like a two-dimensional cyclic. But isn't it too complex logic? Like, now what should I do? Okay, the cycle's lengths are same, right? So we have formed some cycles, okay? That makes sense. That's what I tried doing in a 2D plane, but I was not able to see it there. But now I'm able to see it here. I consider that if we have this cycle and one of them value, the other cycle also should be equal. This I proved very clearly in my mind. How? Because you do a cycle and here you came here. So if you do the same thing on that y, you must come here because the cycle length should be same now. And once the cycle lengths are same, now what can you say? Also that will go to something, right? One of them. Also their cycle length should be same. So it's like cycles. So now you have this cycle. And then let's say some uncycled lengths are present in this thing. Okay? Let's group them by cycle lengths itself. Okay? Whatever the remaining cycles that are left, that are unfilled yet, let's group them by their cycle lengths. Because now each of them should be mapped among each other independently. Let's say we are, because cycle lengths must map with cycle lengths, right? I don't know, but this problem was so good if it gets correct because I'm imagining some 2D cycles that goes on this cycles and this cycles. Like there are rings like this, and those are also forming rings. Like it's cyclic cycle. Where am I now? Mm, I hope this is correct. Okay, now I ordered them via cycle lengths. Okay, so this cycle is already mapping to this one, and we know that already some cycles are being mapped to some cycles. Okay, now your question is, can you form a permutation here? Fuck, it's not that easy to think of. Okay, now we have these cycles and some of them are connected. Okay, some of them are connected. Now we want to make cycles onto these cycles. One thing is clear, these are just line patches so far. Okay? Now, because these are just line patches, because these cycles are just line patches, if you have something that needs to be filled now, the first cycle that needs to be filled, okay, you can choose. Okay, you have cycles like that, you have these chains of cycles. Okay, you can connect them as you like, as long as they form a cycle. Perfect, so far it's perfect, I can visualize everything. And you have to start with the smallest outgoing, and then you have to find the smallest incoming. Only problem now is, can you spin them and then connect, is what I was trying to think. That's being too much. Should they connect directly? Can they spin and connect? This is the question now. If they are like independent things, then you can definitely spin and then connect them. But if it's the same thing, can you spin and connect? No, you cannot spin, because you cannot spin. You must directly connect. You cannot spin because spin can only happen in this direction, right? You cannot move in this direction and then you cannot spin them. Okay? So either you have a choice for this to connect with this one and close the loop here, or you have a choice to connect with the some other tail that is not connected to this, and then you will merge them via union sets. I want to code this very badly, but I can't do it in 12 minutes. I'm not able to call this. Why can't you twist again? I think you can twist. Maybe you can twist. I can see the code. I have twisted the cycles or whatever I have done it, and then I just connected them. Okay. You have to erase the cycles of out here. So what have I done? You have in out. I have cleared this out and connecting them, clear this in and connecting them, and that out will become this in, and this in will become that. Yeah, I'm just removing this y again. This will be the parent. All of them have been connected. It's perfect. And now, while this happens, I will take something which is the minimum out. Okay, I'm taking the minimum out, and then I will find the minimum in, and then I will attach this to that. Now this follows from here. And this will be an asset actually, because that's how we chose, right? And now what am I doing? I'm just attaching all of them. Hey, understand the complexity. Let me just remove that. I'm just trying to connect those two things. You have these cycles, you only connect the cycle once. That's what I want to do. Okay? I only want to connect one cycle outward once. I'll maintain pair copy of pair. Use that to not touch them again. In attaching these things, in attaching these things, I will only attach them once. Okay? Means the cycle has already been put to something. Okay? Now you want to test that this shit is unique now. Will they be unique? They may not be unique. So how to just test that they are unique? If I just test that they are unique, then it's done because all of them are only being set once. If all of them are unique, the cycles are good. And also they should be matching BI. Hey, does this guarantee uniqueness? Because you're only going to something that is in. So it will guarantee uniqueness. So you need not even test for the uniqueness, you have to only test for just testing for this is enough. I don't know if I overcomplicated the problem or it's really great problem. It's not too great if someone knows it already, but if it is first attempt, then it's great. I think it's great. Fuck it. I did good, guys. Today I did good. I'm ending it. My visualization was, you know what I visualized? You guys know what I visualized finally? I was actually intuitively seeing this from long ago. That's why I was trying to draw a 2D plane. But what I finally has done is I have green cycles like this. You see that? Okay, I have some green cycles like this. I'll put some notes here. Okay? And then I have red cycles like this, which come back and connect here. And they can connect anywhere here. Need not be the same thing. That's what I was thinking. Can we twist them? You can't twist them. They need not connect here. You can't twist them because it's a 2D plane. It's a 2D cyclic plane where all that matters is how many straight you go and how many left you take. It doesn't matter. So greens are in this direction. Green arrow. It's a circular thing. Because why is it circular? Because permutations are cycles. That's why it's circular. And because there are two permutations, you have two directions. All it matters is number of this side and number of this side with respect to some value. That's what commutative is, right? Actually, it's if it holds for one length, that's fine. But you can visualize for more lengths too. And why is twist possible? Because all you have to check is come like this. Okay, a bit twisted and number of things you take that side. Now take that side first and then come like this. Now because of the twist you might have came here itself, so the twist is also possible. I thought twist is not possible, so I was trying to be more careful with respect to when same things goes to the same thing. But then I realized that twist is also possible. So it's like you have these cycles that are coiled. It's like a spherical ball. What I mean by that, see, these cycles, this is not on the left, this is not on the right. If these things are in the cycle, these cycles are also in the or in a cycle. I mean, the distance between them and distance between them is same is what I'm trying to say, because this radius is going there. So it's like a complex object in space. If you try to visualize those permutations, then they are commutative. See, that's what it is.